Good day, folks. Many people are asking about more questions regarding my back EMF generator and my setup in general that charges the battery here with the back EMF. And some people are getting confused and are trying to make reference to other devices that are not quite the same but similar. And a lot of people were asking for schematics, and I've been hesitant, not because I have anything to hide, but there isn't much of a schematic to be made because I try and keep things as simple as I can just for simplicity so I can understand what it is I'm doing myself. So with that said, and with the shaking with my Parkinson's basically, I don't feel confident building the 555 timer kits and modules you can get. So basically someone who's into that, you can build your own controllers and be very elaborate. Bedini built his from scratch, but I wouldn't be able to do that. So what I've done, and you will understand why I haven't posted a schematic, I will try and go into details of this generator here. And I will even try and doodle the schematic as I go here with you, on the spot even, or as close to one as I can. You see, this here is a module I got on eBay. It's a square wave generator. As you see, I'm really taking the time to zoom into everything here because people want to know the details. Basically, my way of thinking at this is the back EMF method is not really that important. There's a million ways to do it. You can find schematics online. Pulsing a coil is not new. This has been around. There's been discussions of this back into the Usernet groups. And there are text-based schematics of this stuff even. So with that said, I just chose the easiest method I could think of, which was buy a pre-made module. This is really small, as you can see. And there's two controls here, frequency and duty cycle. As you see right now, I got it set. This is the coil here. Every coil has a sweet spot of operation. And I made it myself, and I wanted it. And people want to know what the wire is. It's telephone, just regular telephone 4-wire cable here. And what I've done is each end, I've shorted them all together, so essentially it's one big wire. And the people want to know the length. It's about 350 feet of that. The impedance is 1.9 ohms. So the idea here in building these coils is you want the I assume that the coil should be very big. The biggest conductor you can find, I found the phone cable, and as much of it as you can, and at the same time trying to keep that impedance as low as you can. And that's part of it, and the switching as well. So I'm going to show you what goes on here. Back to my, this is the controller here, which only requires 6 volts to operate. Now I'm feeding 12 volts DC, but here we have our voltage regulator, which takes the 12 volts and gives us 6 volts just for this here. And this pulses the 6 volts, it uses its own voltage, into this resistor here, which is basically the base resistor for my NPN transistor, which is acting as a anti-E181. For those who really want to know, very generic NPN transistor. And this basically switches the ground into this coil here. And right at the end here where the negative would come in, I've got the diode, which takes the back EMF in and converts it to the positive into the battery here. Now the input is connected. This is my power supply, which feeds this whole thing here, which connects to the inverter, which runs on the battery here. Now there's a difference. A lot of people get the things mixed up, like they will say, is this a flyback, is this... There's differences, and people will sometimes nag and say, you know, well, what you're putting in is what you're putting out, but there's different systems at play, and when you can integrate those systems together, that's where sometimes you get the over unity. So I'm going to explain that, and there are differences between what they call the jewel teeth and the flyback oscillators. So when you build the transistor, basically, the one that lights up an LED with a dead battery is a popular one that people claim is free energy. Really, it isn't. It's very efficient, and what it does is, see, you've got your transformer here, which would be, I'll just draw that really quick here. That's your transformer, and I have a center tap right here. Okay, and then you have your primary and secondary here. I'm sorry if this looks bad, I'm not the best drawer. So basically, when we set up the flyback system, you've got your transistor. We'll say this is our positive here, so we're going to go plus, so we're going to go 12 volts plus here. So this is where our plus goes, so we have plus on this side here and plus on this side here. So what happens here, we have our plus going into our transistor here, and this is the collector and the base and the emitter. This is really crude, by the way. I know, I'm sorry about that. So here's your transistor, and on the other side here we go into the base, and here's your base resistor here. So we'll say 1K. Just doing this roughly here. There's your base resistor, and your emitter, this is NPN, NPN right here, NPN, and your emitter is your negative, your 12 volts negative. So basically, when you connect this kind of a circuit here, what happens is you got a free running flyback oscillator, and we're ignoring the secondary for now, but I'll get to that. And if you look into a scope, this is kind of like, it's going to be sharp, but this is the waveform you're going to get. It's going to be kind of like, see, I'm a bad drawer, this being the middle here. So this is being your positive side, and this would be your negative side here. And this is what basically happens in your scope. Now this is the voltage here, peak on the positive and the voltage peak on the negative. So you got kind of like a sine wave here going on, and the current doesn't actually happen here. See, it follows a little later, so it actually kind of like, this is where the current, you don't see it, but this is every pulse, this is where the current follows along. So what I'm trying to get at is, depending on the transformers, well, your coil here, the length it turns will determine the peak to peak, basically. So the more turns, the higher voltage. So this is a way to increase your voltage here without stepping it, like without needing a step-up transformer. But you're sacrificing and your current here, because you've got this lag here and this space where the current can drive along with the voltage. So your dead battery, which might be, see, I'm showing you 12 volts here, but let's say we want to do this into a the joule teeth, this would go down to maybe 0.8 volts here. So this would be 0.8 volts. So the whole system would start self-oscillating with just a 0.8 volts left of battery. But you see what's going to happen here, it's going to use up the current that's left to give you that extra voltage spike here. So for a few moments you're going to get what seems to appear as a source of free energy, and if you put something small like an LED to it, you're going to get, you know, I'm just going to draw it here, LED here, it's gonna light up for maybe, who knows what, half an hour, until your voltage goes to around 0.4, and then the base no longer triggers. So this is one system which is pretty interesting. It's efficient, but it's not free energy, and people think this is what I'm doing and this is good here, but it's not. So back to my system here. What I'm doing, I'm going to see if I can draw this. It's hard while I'm holding the camera. So here's my big coil right here in the middle of it all. So this is my big coil here. This is my, we'll call it L1. And here's the outputs here. And that's going to go to, we're going to have our controller here. So this is going to, so we're going to have our positive here, and our negative goes here. Okay, so now we're going to have our NPN transistor, or NTE 181, and this is we're going to go collector, base, emitter. This is just me being quick here. And this is going to be a really bad looking schematic, but anyways, people want to see how I'm doing it, so here it is. So NTE 181, and the collector here is the plus. So it says the base is the trigger. So we're going to go here, and this is my R1 here, and this goes to my modules output. So this is the square wave generator. Just so we know, that's the square wave generator module. And this is the out. This is the pulse plus out. And this is the input plus and the input minus. Right here. Okay. And this controls, this is the pulse, which controls the base of the NTE 181. And the emitter has our 12 volts plus, sorry, this is NPN negative. This is negative, very important. The emitter is negative. So this is where 12 volt negative goes in. And what this does is it switches our negative through the collector here, which goes into the negative side of our coil here, like this. And the positive here goes directly to the 12 volts positive. So 12 volts positive here, 12 volts negative there. And here is, this generator requires 6 volts. So this is the 6 volts plus in, 6 volts minus here. And I have also a voltage regulator, 6 volts. So I'm going to put the voltage reg right here. So I'm just going to call it reg 6 volts. So this is my plus, this is my negative, again very quick, and this is my regulated output. So again we put 12 volts, input goes into our 12 volts input, and our negative goes into our negative here, and the plus goes to plus here, so that's our 6 volts plus, and our negative of course goes to our common negative. So this is essentially it. And what we have here, this is the plus, this is the negative. So I've got my diode here, which is D1, which is like this. So on the negative, so that I can pulse, so this converts it to positive during the back EMF event. So it's going to go through the negative of the coil, go into plus because it's the back, and this goes into the plus of my charge battery here. And then there's the negative, and the negative would go into where the coil's positive connects. So this is the whole, it's really, so the controller being 6 volts, which runs through the 6 volt regulator, which pulses a square wave 6 volts through R1, which triggers the base of the NTE181, pulses the 12 volts negative in through the collector, then to the big coil, the diode to get the back EMF into the battery charge. So this is very crude, more of a diagram, not so much of a schematic. So now you see why I didn't really have much of a schematic, because there's not really one here to build once you see what I'm doing here. Now what's the difference with this system here is you're going to get a different pulse than what it's not much a sine wave anymore. So I send a square wave, and as you remember here, it's set to 33 Hertz right now, 1% cycle duty. So what that's going to do is that 33 times a second, I'm going to have a pulse because it's very sharp at 1% here. So what it's going to look like, it's going to look like a line here. And then there's going to be another line. Then another line. Then another line. And it's going to go on like this. That's going to be my pulse, which is going on at, since we're switching the coil, it's pulsing the coil at 12 volts. So the peak here would be 12 volts. Okay? So this here would be the flat. So this would be 0 here. And then you got your negative. So you're going to have negative 12 down here. So what's going to happen now is, because we got such a sharp duty cycle, it's just a line. It's no longer that sine wave you were seeing earlier. So this takes a lot less current because there's no time now. You know, you don't have that bump for the current to like I had earlier. Yeah, see? We don't have this going on anymore as much because it's so sharp. The current doesn't have time. So it's mostly a pure voltage action that's going on now. So this is our trigger at 12 volts happening at 33 hertz. Bang, 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 bang. Now what happens with the back EMF, you get a lot more. This is going to go over the scale down here, but it's going to follow just a little bit after, like that. And I'm going to show you that right now on the scope to show you what I mean, because this is actually running right now through the battery. So I'm going to first show you the trigger, okay? So this is the line here, which is the 0, and this is what we're putting in as a trigger, okay? So, you know, this is detecting about 15 because I got the 13 volt power supply here, which makes sense. So this is the trigger that we're pulsing through the circuit here, through the transistor. And I'm showing you the first. This is the pulse. So now I'm going to change the view, so I'm bringing this up so you're going to see the other half of the cycle here. So I was only showing you the first half because I want to show you the difference. See, now we're about equal, but see, I've got a lot more to go because we're not at the peak yet. That's the back EMF. You see it now? There's that sharp spike on the other side. Much more on the negative end, which is the back EMF, which is that line. You see? I'm still bringing up. See, now we're up there. The negative is really. So now once I brought the line, I can see that 35 volts. I don't know if you can see it there, but the rating is showing these lines here, these negative voltage peaks of the back EMF is coming back at 35 volts, which is not bad. And as you see, it's a mostly voltage because you see that line here, you know, it's a very sharp, very, very sharp. Now what's interesting and what makes this different than the Flyback here, I will show you that once. Okay, I'm going to go back to the positive, which is the trigger here, which is, as you see, much less. Now, the reason I use 1% duty cycle here is to use, again, my philosophy of using the very little current as possible to trigger what Bedini would call the vacuum energy, the back EMF. So we just want to use the back EMF and utilize that. And what happens with generating the back EMF is if you use anything more than 1%, you're just wasting your current because you're creating more of this kind of a thing. And me personally, I want to get away from that because I want to not use current. I want just pure voltage spike if I could do that. So I'm going to show you what happens here when I bring the duty cycle up. So I'm going to bring it up right now and you'll see what happens on the scope. It'll increase that line and will become, see, I'm bringing that up now. So I don't know if you can see it, but here's the spike here starts, and then there's what looks like another line next to it. Well, the space in between, that's the duty cycle. So that in between space is where the current is able to utilize itself. It's hard to see on the scope there, but it's that. So now I brought it up to 7%, so I'm going to bring it up to 8, 9, 10, and you see the line, the width gets, now you see it more, that line. So during that time is where the current can follow along. It gives the current time to follow, to drag along. But surprisingly, well, not really surprisingly, but interestingly, the more duty cycle you put, we're going to go back to the other negative part, see This is the trigger right here at first, and then you get the back EMF right after, right? Right when the voltage stops, poof, there's the back EMF at the off time, right? Because that's how it works. But see how the back EMF remains sharp? It's not affected by the duty cycle. The duty cycle right here, this is the time. This is your beginning, your end. But then you got the spike, it's still just a spike. But now we're using more current, and we haven't done anything to the back EMF. So now I'm going to increase this to 25%. See? Now the line is even, now we're using current, but the back EMF remains the same. So I'm going to show you. And what happens is, see, we're still getting 32 volts. So the voltage doesn't increase or decrease, and we end up using more current. So then it becomes less efficient is what I'm trying to get at. So it's very important with these coil kind of setups here to keep, so I'm going to bring it back down here, the duty cycle, to keep the duty cycle very sharp so you don't, because if we're looking for if it's the back EMF method you're looking for here or you're experimenting with, increasing the duty cycle isn't going to give you more or more intensity, more power, more current, anything like that. It's just going to make you end up draw more power that you're not going to end up using in the system, which you're going to waste, and it's going to end up heating your transistor. You're just going to waste it. And I just want to make a big point that, see now, and my trigger looks just like a line because I got it to 1, but that's all I need, because if I show you the other half of the cycle, here's that big back EMF spike, which is the exactly identical spike. It's there, want to or not, whether it's 1% or 50% cycle duty. At 50% we'd be wasting a lot more power to get that same back EMF spike. If people would wonder why all of a sudden they don't seem to have anything that looks like over unity, if you're using half of your current, you may never get it. So again, it's to trigger what Benini calls the vacuum at the most little energy you can to receive something back out. Now, the goal here is to get a high as you can voltage, the highest voltage back EMF. The better, the more the better. But unfortunately, single batteries like this could have a hard time down the line with this radiant back EMF. So Bedini's version of that was either add more batteries in parallel, or higher voltage commercial, like those big 60 volt batteries, which would offer less resistance. So the more voltage for the radiant, the better it is, the more pronounced the effect of over unity looks like for the lead acid batteries anyways. And now as you see here, this is a single coil system, and there's a lot of space here. And what we want to do is, if I increase the frequency, my voltage goes down because I'm at the sweet spot here. This is where this coil operates. So the only way would be to add more coils, and Bedini figured that out later. So that's why his mechanical wheels would have like 4, so this would fill out, and with the timing they would pulse just right. Now with the 4 you'd get an obvious over unity if you're using basically nothing as a trigger, right? So that was one of his little secrets. He didn't tell you that right away, but he went on for himself later on building the multiple coil systems for exactly that reason. For the solid state method, how to increase the coils, well, there's a few ways of doing it. One way to make this more efficient, because we're using back EMF, is if we want to increase the voltage spike here, is instead of going to the battery, we use this as a primary stage, and the back EMF side would drive basically another coil, which is even bigger, which would up our back EMF spike, and on and on and on. It would go like that until we would get 100 volts if we want 100 volts without stressing the additional input trigger here. So during all this time that we're talking, the battery's been doing its thing. I've shown a million demonstrations of this right now, so that's not what the focus was. But I just want to show you, you know, this is what happens. It's still charging. And this is running on itself here. The inverter is connected to the battery. 12.89 now. I'm going to have to shut it off soon. But as we talk, you know, we've been talking for about 27 minutes now, and in half an hour it's still charging itself up just from this. So this is basically it right here again. I'm sorry for the quality of the doodles here. I will try and post something a bit more professional down the line, but I just thought I wanted to share you that and make the point again that if you're using back EMF, you really don't need very much, and if you put more current into the system, you're just wasting it. So the better way is to increase the voltage, like I said, or increase the coils to get more of those spikes. That will increase the effect. I hope you enjoy, and again, any hints and suggestions welcome.